Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. Shown below is the structure of methyl acetate with three different alpha, beta and gamma carbon oxygen bonds. Okay, so this is alpha, this is beta, this is gamma. The correct order of bond lengths of these bonds is okay. So the chapters involved is general organic chemistry. So we know that resonance is said to occur whenever for a molecule we can write two or more Lewis structures. Okay, so resonance occurs when for a molecule we can write two or more Lewis dot structures. Okay, and those Lewis dot structures should differ in position of electron but not in the relative position of atoms. Okay, very important. So they should differ in position of electron and not in the position of atoms. Okay, and the various Lewis structures that we can draw for a molecule are known as canonical or resonance structures. Okay, the various Lewis structures are known as canonical or resonance structures. And the actual structure of the molecule is a resonance hybrid of all these Lewis structures. Very important. So the actual structure is the resonance hybrid of these canonical or resonance structures. Okay, so methyl acetate may be regarded as a resonance hybrid of the following two structures. Okay, so one of these structures is already given to us, that is CH3 C double bond O, single bond O, CH3. So we have two lone pairs here and also two lone pairs here. Okay, to draw the other resonance structure of methyl acetate, so using double headed arrow, so I will shift this electron pair here and I will shift this double bond pi electrons to form a lone pair. Okay, so the resonance other resonance structure will look like this: CH3 C single bond O, 1 2 3 4 5 6 negative charge on this oxygen, double bond O, positive charge on this oxygen, and CH3. Okay, and the hybrid will look something like this. Okay, so the actual molecule or the hybrid will be CH3 C single bond O, single bond O, CH3, and look at these dots. Also look at these dots and also look at the charges. It's partial positive charge and here we have a partial negative charge. Okay, and so first thing is to observe is the charge. So in one of the resonance structure there is no charge. In one of the resonance structures there is minus charge and plus charge, and in the hybrid we have partial negative and partial positive charge. Okay, next we have to look at the bonds. In one of the resonance structures there is a pure double bond and a single bond. In the other one we have a single bond and a double bond. Therefore in the hybrid we have partial double bond character, partial double bond character. It's in between a double and a single bond. It is neither a pure double bond nor a single, nor a pure single bond. Okay, and also let us look at alpha, beta and gamma. So this is alpha, beta, gamma, alpha, beta, gamma, alpha, beta and gamma. Okay, so the gamma carbon oxygen, that is this bond, is a pure single bond because there is no resonance or double bond character involved. It's a single bond, and even in the hybrid it's a single bond. Okay, so therefore it will be the longest because we know that bond length of a single bond is greater than bond length of a double bond, which is greater than the bond length of a triple bond. Okay, so one thing that we know is that gamma carbon oxygen bond is a pure single bond, since there is no resonance or partial double bond character, so therefore it is the longest. And we should also know that bond length of single bond is more than bond length of double bond, which is more than bond length of a triple bond. Okay, now coming to structures 1 and 2, we should know that structures which involve charge separation of positive and negative charges. For example, look at structure 2. We have charge separation here of positive and negative. So these structures where there is charge separation are of higher energy and therefore contribute less towards the hybrid. Very important. Okay. Structures which involve charge separation. So let's say this is structure 1, this is structure 2 of positive and negative charge. Example, we have structure 2 are of higher energy because of charge separation, and therefore contribute less towards hybrid. Okay, and therefore structure 1, that is this guy with no charge separation, so there is no charge separation, is the main or the major contributor towards the hybrid. Okay, and in one we have alpha, which is a C double bond O, and beta, which is a C single bond O. Okay, so in the hybrid you can see alpha and beta both have partial double bond character. Okay, but since structure 1 is a major contributor, therefore double bond character of alpha is more than double bond character of beta. Okay, you can see in the hybrid there is double bond character in both of them, but out of these two contributions, one is the major contribution, and in one we have a double bond here and a single bond here. So therefore the double bond character of alpha, that is this one in the hybrid, is more than the double bond character of beta in the hybrid. Okay, so right, alpha and beta both have double bond character in hybrid, but one is major contributor towards the hybrid, so therefore double bond character of alpha is greater than double bond character of beta. Okay, so therefore we know, right, double bond character, if it increases the bond length decreases, so therefore gamma has the highest, then we will have beta, then we will have alpha. Okay, so therefore this is the order of the bond lengths of these bonds. Okay, therefore the final answer is gamma bigger than beta, which is greater than alpha. Okay, thank you.